Okay, so let's talk about requirements-related information. I mean, there are requirements, but there's a ton of other stuff that you have to kind of gather together if it's not already in your head. Now, sometimes, if you're doing an air traffic control system for the 14th time, you got a lot of knowledge in your head. Or if you're doing billboard websites for the 14th time, the requirements are already in your head. So you don't need a lot of external support, a lot of stuff written down, because you're an expert in that particular area. There may be some new things that you can focus on, but in general, you got a lot of information that's important. Okay, so what am I talking about in this requirements-related information? Well, first of all, you got to know the application domain. So if you're doing an airline reservation system, there are certain things you want to know, flights and whatever. If you're doing an aircraft maintenance system, right, I'm kind of in the same domain of aircraft, but now it's a whole different set of things I have to worry about, right? So you not only need to understand the domain you're working in, and some of you are experts in that already, and others don't. And so we have this terrible word, ontology. Blech, Unfortunately, that's the word that people use for all the concepts that are in a particular domain. And I'm going to show you an ontology here in the next slide. The other things you need to understand as clearly as you can is the problem or opportunity that you're about to work on. You need to know who the stakeholders are, and there generally is a larger population of them than you know. The solution context, because you're developing it in the context generally of other systems and other solutions for other problems. And so your solution or opportunity needs to fit in. Right? The risks of whatever it is you're doing, the assumptions that you're making, the available restrictions on feasible solutions, i.e. the requirements, and then the requirements, risks, and mitigations. A lot of stuff to know in order that you don't get surprised. I mean, you can only know some of this, and you can lay a lot of code down and wind up with 1 million lines, and then somebody goes, I'm sorry to announce that we missed this whole area that we have to produce some stuff for before we ship. Okay? That is not a message that anybody wants to carry, because you know what happens to messengers of bad news. All right, so here's an example from one of my interest areas, which is autonomous vehicles. I'm interested in this because I have 5 beautiful grandchildren who don't need to be in an autonomous vehicle. They just need to be on the roadway with an autonomous vehicle. And if those vehicles aren't behaving properly, they're at risk. So as a grandfather, I'm very interested. Here, you all understand those. Look at the sets of things that need to be understood in the domain you're working in, right? So you got entities, hazards, procedures, rules, yada, yada, yada. A lot of stuff. The requirements for autonomous vehicles. We've got a dozen or more companies around the world, all basically working the same problem. How many of you have ever seen the requirements for the systems that they are so proudly showing on LinkedIn? No hands. Well, there's a big shock, right? Okay, now they're all private companies, you say. They're very concerned about intellectual property. Is the requirements for self-driving vehicles intellectual property? Well, a company thinks that way, says, oh, maybe my competitor will not figure this out and they'll kill a bunch of people. Is that going to be good for me? I don't think so. So it's like the entire industry should be really, really interested in coming up with a core set. Now, if you're doing an automated bus and somebody's doing an automated golf cart, whatever it is, yeah, there are going to be differences. But at the core, if they're on public thoroughfares, right, they basically are solving the same problem. So naively, I think there should be, open source requirements. What a concept. All right, anyway, moving right along. So here's an example of a goal statement, right? For our autonomous vehicle, the software must control the driving behavior of an autonomous vehicle within a specified ODD, which is operational design domain. That means you say, we're only going to work in here, and if we go outside of that, we park. At SAE level 5, that's completely autonomous. No human intervention, interaction. I'm sorry, no, interaction is fine because you get in the vehicle, you want to tell it where you're going, okay? So there will be some interaction, but no control. After that, by reacting to sensor input and behavior rules. Oh yes, this entails a fairly comprehensive list, but not complete, of functionality, normal stopping and starting. Now this is just the beginning, folks, because the next slide has stuff you need to do continuously, right? So you need to do the stuff on the previous slide occasionally. This you need to do all the time. And we also need to be doing a bunch of other stuff. So this list goes on and on and on. The likelihood that the same list, that an adequate list exists in all of these dozen or more companies is 0. Detecting and mitigating software and system failures. So there I am driving down Excelsior in my very old Vega. Everybody said, don't buy a Vega. Said, Vega's all we can afford. So I'm doing 30 miles an hour down Excelsior, and suddenly the engine is gone. Right? It is not dropped out, which one might expect from a Vega, but actually just stopped. And fortunately for me, I am within half a block of a service station. And there's nobody sitting in the on-ramp, if you will. So I'm able to coast and turn. And I thought, if this happened when I was doing 60 miles an hour down Highway 100 or 169, possibly there would have been a different outcome. And when I pulled in and I said to the guy in the service station, my motor just died. He said, oh yeah, they do that. What? That wasn't in the list of features of Vegas. The motor dies. Single point of failure, folks. If you're safety critical, you don't design single points of failure. One component cannot fail and the system crash. Okay? That's just a no-no. The bad news is this is just a partial list of the hazards that would be faced by an autonomous vehicle, right? We got system failures of a variety of ways. We got vehicle condition problems. We've got roadway conditions, traffic conditions, weather conditions. And those are just individual elements. What happens if we have a pair of those? Bald tires and icy road, I don't know. Make your pick of what you're going to do. How in the world are you going to mitigate that? That all has to be understood. And I'm afraid that AI is not going to help us here, folks. So this is what risk mitigation is all about. future engineer in the making. Okay, developing mitigation methods. So when you've decided what individual hazards from the previous slide you saw and which combinations, the question is, what am I going to do about it? So if the motor dies on the roadway and the vehicle is moving and a safe and traversable glide path, oh yeah, you know exactly what I'm talking about, right? So guess what? I need a glossary definition of what a safe and traversable glide path is to have this make any sense at all, right? So if those conditions are true, then I'm going to do all this stuff. And again, I'm sorry, AI is not going to help you. First of all, will the vehicle be able to detect the fact that the motor has died? Then what should happen when the motor dies and the vehicle is stopped in a safe place versus stopped in a dangerous place? How about when it's moving but can safely stop, or worst, moving and it can't safely stop?
Andy Williams can't get used to losing you. Which dog? The Beatles, the English band, covered, didn't they? That's where it comes from.
What I'm saying here, folks, is we got some risks that we really don't have a nice, clean, clear mitigation for. We're kind of winging it. And whether the winging it is going to work in all the situations that it occurs, even if they're very rare, right? We're talking about tails of the probability curve here, folks. Okay? But you're going to be just as dead if you don't address them at all, right? Rather than putting a little thought behind it. We said there are functional and non-functional, or we have 19 different kinds of requirements. And I want you to notice, now not all the types are going to be relevant, right? So if you don't have a supplier, then you have to worry about basically the requirements for the suppliers you don't have. And I also want you to notice how often the word developers show up here. Yes, of course, basically every book or paper I've ever seen says, oh, we got to get the customer involved. Customer involvement is really key. And without question it is, folks. But that's just the beginning of the story. Developers have an enormous responsibility in a lot of areas that I think most of them don't understand. They don't understand their responsibility, and if they said, yes, that's my responsibility, they don't understand what they need to do. So that is something that an essentially complex model can do for you. It can show you whose responsibility is what and the things that you need to understand in order to do an adequate job, right? Okay, now, whenever you automate any area that has previously not been automated, it becomes really, really important to manage the terminology, because everybody has their own private terminology. And so in an organization, when two people communicate and they see a phrase and the one person who wrote it meant this and the person who's interpreting it meant something slightly different, and sometimes those underlaps don't matter, and sometimes they're deadly. So we need glossaries. Another topic that's kind of boring until you get it wrong, right? Now we know the Tower of Babel actually is an example of something that's not too dangerous. Why? Because when the person next to me isn't talking a language I understand I don't understand. But this guy is much more dangerous. This is the famous Tower of Unrecognized Ambiguity. So now the person next to me says something, and I go, I got it. No, you don't, but you think you do. So for new domains or applications, terminology management is very important. Precise definitions are a pain in the neck, and they're completely inhuman. We do not go around precisely defining the terms that we use. My wife sends me to the store for orange juice. I get to the store, and I thank somebody that cell phones were invented. Because now there are 374, it's not like the cereal aisle, but it's almost as bad. There are many, many different kinds of orange juice. So I need a little refinement of my mission here, okay? That's normal, folks. That's how we operate, and I'm not proposing that we suddenly, move to Vulcan and get ultra precise about everything we say. That isn't going to happen. The value of a precise definition is directly related to the difficulty in creating it. If everybody shares a common definition of a term, and I go, what does this term mean? And 2 minutes later, we got it written down. Not very valuable. But on the other extreme, if it was really hard to get consensus on a term, what I've done is avoided a lot of problems in the future now that we understand that we don't understand and we don't have a common understanding. And we've got to come to one so that we can then, when we receive our marching orders to do something, I understand what the words in the marching orders mean. Okay, so now, is this creature near the roadway or not? Why do I care? Anybody want to tell me why I care? I'm sorry? He could jump in, yes. Yes. Volvo did their automatic vehicle experimentation in Australia. They had algorithms for sensing animals, non-humans, that were moving in the roadway and what to do with it. But they had never encountered a kangaroo before. So when it went airborne at the driver, they weren't prepared for that. And as a matter of fact, they announced a 4-year slippage in the delivery of their self-driving car. I don't know whether they made that or not, but I thought it was just so wonderful that they recognized that there were a lot of things out there that they hadn't counted on. Whether this is near the roadway or not depends on the jumping range of that particular creature. If it's bigger and has a bigger range, the very definition of near changes, because we're talking about risk here.